Hello. In this video, we're going to derive one of the fundamental trigonometric identities, the angle difference formula for cosine, cos, beta alpha. We'll use a cool visual approach involving vectors on the unit circle and a powerful tool called the dot product. Let's get started. First, let's set up our framework. We're working in the standard Cartesian coordinate system. Imagine a unit circle centered at the origin. That's a circle with a radius of exactly 1. Now, let's define two vectors, starting from the origin O. The first vector, OA, ends at point O on the unit circle. We'll call this vector A. The second vector, OB, ends at point B, also on the unit circle. We'll call this vector B. Since Z and B are on the unit circle, both vectors Z and B have a length, or magnitude, of 1. These are unit vectors. Let alpha be the angle vector A makes with the positive x-axis, measured counterclockwise. Similarly, let beta be the angle vector B makes with the positive x-axis. Because points Z and B lie on the unit circle, we can easily find their coordinates using trigonometry. For point O, associated with angle alpha, the coordinates are cos alpha, sin alpha. For point B, associated with angle beta, the coordinates are cos beta, sin beta. Now, what's the angle between our two vectors Z and B? Looking at our diagram, if we take the larger angle beta and subtract the smaller angle alpha, we get the angle between them, beta alpha. This is the angle whose cosine we're interested in. Now, we introduce our key tool, the dot product, or scalar product, of two vectors. The beauty of the dot product is that we can calculate it in two different ways. First, the geometric definition. The dot product of A and B is the product of their magnitudes multiplied by the cosine of the angle between them. So, AB equals AB cos beta alpha. We already know that A equals 1 and B equals 1 because they are unit vectors. Substituting these in gives a B equals 1 times 1 times cos beta alpha, which simplifies beautifully to a B equals cos beta alpha. Let's call this equation I. Second, the algebraic definition. The dot product can also be calculated using the components of the vectors. If A equals x, A, and B equals bx, by, then a B equals x asterisk bx, plus A asterisk by. We know the components of our vectors, A equals cos alpha, sin alpha, and B equals cos beta, sin beta. Plugging these into the formula gives a B equals cos alpha, cos beta, plus sin alpha, sin beta. We've just found two different expressions for the exact same value, the dot product of B Since both equation I and equation II are equal to a b, they must be equal to each other. Setting them equal gives us cos beta alpha equals cos alpha cos beta plus sin alpha sin beta, and there it is. We have successfully derived the angle difference formula for cosine using vectors and the dot product. I hope this visual explanation was helpful. Thanks for watching.